Hello everyone, and welcome to the implementation of binary search lecture. So here's your example notebook. It's called Implementation of Binary Search, and you have two versions, an iterative version and then a recursive version. So we're going to go ahead and go through both of them here, code them out, explain what we're doing along the way, and then you have the reference of the notebook in case you want to go back and check it out. Let's get started. I went ahead and started a new notebook here. I'm going to start off with my first function, just called binary search. It's going to take in an array and an element. Let's go ahead and zoom in here. Then I'm going to say my first and last index values are going to be variables. I'll say first equals 0 and last equals the length of the array minus 1 because indexing starts at 0. And then I'll say found is equal false. And we'll just use found as a marker just like we did for sequential search, whether or not if we found it or not. The target element, that is. Then I'm going to say while first is less than or equal to last and not found, meaning we haven't found our target element yet, we'll go ahead and make a middle marker. In that case, we'll call mid a new variable, and that's just going to be first plus last divided by 2. And then what I'm going to say is check if there's a match found. If there's not, I'm going to set up new midpoints. Meaning I'm going to go ahead and say if at that mid location we found the element, I'll just say found equals true, and that's the end of the analysis there. Otherwise, else, I'm going to go ahead and say if the element is less than that value, then my last equals mid minus 1. Else, my first variable is going to be equal to mid plus 1. So all this loop is doing here, or this block of code, is just basically deciding if you're going to use that lower half of the list or the right half of the list. This is the case for lower, this is the case for the right half. And after that while loop is done executing, meaning we've either gone through all the possible elements through our binary search, or we just actually found it and it equals true, at the end we just return found. Okay, let's go ahead and run this, make sure we have no errors. I'm going to go ahead and make an array. And keep in mind the array must already be sorted. We're taking further advantage of the fact that we have a sorted array. This won't work on an unsorted array. Then let's go ahead and call binary search on the array, and we'll look for, let's say, 4. Okay, perfect. It's in there. Let's look for 10 just to make sure. And now let's look for an item that's not there, 13. False. Okay, great. So our normal version of binary search implementation is working. Let's go through it one more time just to make sure we understand what's going on. We set up a function to take in the array and the target element you're looking for. We set up two variables, first and last, which are basically index markers. Then we set found is equal to false. And then we're going to continually go until first is less than or equal to last, and we haven't found the element yet. We set a variable called middle, which is just first plus last divided by 2, to get that middle index of that list, or the sublist. And then we say, if at that middle index we have found the element, then it equals true. Otherwise, if the element is less than, the target element that is less than the element at that middle, we're going to set last equal to mid minus 1, meaning we've chosen that lower half of the list. Otherwise, we'll set first equal to mid plus 1, meaning we've chosen that higher right half of the list. Once we've done through this while loop, we'll just return the found boolean. Either we found it, so we set it equal to true, or it was never changed and we never found it, meaning it was equal to false. All right, so let's go ahead and implement a recursive version of binary search. So what we're going to do here is start off by, let's just go ahead and clear out these cells. And I'm going to go ahead and say REC for recursive, BIN for binary, and then search. Takes in an array and an element. Remember, for recursive algorithms, we need to start off with a base case. In this case, we'll say if the length of the array is equal to 0, return false. So what we're going to be continually doing is basically recursively calling our binary search function, but if we finally got an array that's equal to 0, as we keep splitting it, then we know we never found the element. So that's our base case. Let's go over the recursive case. So we set a mid, that middle variable, equal to the array, the length of the array divided by 2. And similarly to the last implementation, we say if the array at that middle index is equal to the element, then we just return true, we found it. Otherwise, we'll say else. We're going to call this again on the second half, or call it on the first half. So what I'll say is, if the element is less than the value at that middle array, I'm going to return a recursive call here. I'm going to say REC binary search, and I'm going to call it on that second half of the array. Otherwise, else, I'll return a recursive call on the array from mid plus 1 all the way to the end. And this is really similar. This is just a recursive version of choosing which half of the list to continually go on. So if we scroll, oh, we don't have it anymore. But if you remember from the previous, let me just hop over to Jupyter Notebook so I can show you. We had essentially this set of midpoints where we went either for the lower half of the list or the higher half using this comparison where we set up our last and first variables. We're doing the same thing here except for a recursive call where we use index slicing to pass in which half of the list we want to recursively continue on. Okay, let's go ahead and make sure we have no errors here and that it worked out. I'll call it on that same array. Let's just go ahead and print that array, make sure it's sorted. Okay, we're good. Call it on that array, and I'll search for the item 3. Great, it's in there. And if I search for 13, we get false because it's not in there. So, looks like it's all working out. Go ahead and review the Jupyter Notebook where it has comments at every step. Put in print statements if anything's not making sense for you. But again, hopefully this should have been a pretty basic idea of just binary search. You're splitting that list in half, continually checking if that middle point indexed element is equal to the element you're looking for. If not, you just split it in half again, depending on whether this is true or not. Your target is less than the array value at that middle index. Okay, that's it for the implementation of binary search in 2 versions. Make sure you really understand binary search, just the logic behind it, because you're going to see that concept again and again throughout various interview questions. All right, thanks everyone, and I'll see you at the next lecture.